Alrighty, in this video we're doing induction with matrices. So usually with these ones you end up making a conjecture as well as proving your conjecture. So we're going to be doing that for this question. I encourage you to use your calculator with the matrix stuff, just so it makes it a bit easier. So we're going to enter this matrix in our calculator. You go into the matrix menu, 2, 0, minus 1, 1. You can do this on a Texas as well, it just looks a little bit different. And then we're going to go exit out, shift matrix, alpha A squared. Technically I should have called it B for consistency, but oh well. This is 4O minus 3, 1. So what I'm going to do is B is 2O minus 1, 1. B squared is 4O minus 3, 1. B cubed is shift matrix A cubed. 8O minus 7, 1. And B to the 4. Shift matrix alpha A to the power of 4. 16O minus 15, 1. All right, so those are all the matrices there, essentially. To predict the value of Bn, so if we have a look, what's happening with this top left term? So that's A. Bn is, well, this is 2 to the 1, this is 2 squared, this is 2 cubed, this is 2, 4. So it looks like that top left entry is 2 to the n. Pattern on the top right is pretty easy to spot. It's just 0 all the time, same as the bottom right. It's just 1 all the time. Now, these are always 1 less than powers of 2, so I'm going to go minus 2 to the n, take 1 on the bottom left there. That's a bit tricky. The other prediction that you could make, 2 to the n, 0, 1, you could expand that out and write as 1 take 2n. So both would be correct. Prove your conjecture using induction. So, so step 1, well, we've always got to say, let Pn be the statement that b to the n equals 2 to the n O 1 take 2n 1. So you say what you're trying to prove. Step 1 is going to be to prove P1, which we did in A. We actually proved all the way out to P4, which was good. Step 2, assume PK. So assume that b to the k is 2 to the k O 1 take 2 to the k 1. And again, that's just rewriting what our n thing was, but with k. So we're going to label that as star. Step 3. Prove p to the k plus 1. So what we want to show, we're going to write that down, want to show that b to the k plus 1 is 2 to the k plus 1, O 1, 1 take 2 to the k plus 1. That's what we want to show. So let's do that. All right, so b to the k plus 1, we're going to split it up into b to the k times b. And we know what b to the k is. So it's this thing. So it's 2 to the k, O 1, 1 take 2 to the k. And then b itself was 2O minus 1, 1. Now b to the k was that whole matrix there. So we were using star. Now we just need to do matrix multiplication. So down here. So this first term is 2 to the k times 2 plus 0 times minus 1. Then we got our next bit, which is going to be 2 to the k times 0 plus 0 times 1. Then we're going to do the bottom bit of the matrix. One take 2 to the k times 2 plus 1 times minus 1. And then we're going to do our bottom right bit. 1 take 2 to the k times 0 plus 1 times 1. There you go. So it's quite a lot, but it should simplify down nicely. That top left entry is just 2 to the k times 2. And they go pretty slow here, just so we're really clear. This is 0. This is 2, 1 take 2 to the k, take 1. And then this bit here is 0 plus 1. All right, so that top left bit is 2 to the k plus 1, using our index laws. This is 2 take 2, 2 to the k, take 1. And then this is 1 on the bottom right. Now, if you think about it, 2 take 1 is 1. And then that bit there is 2 to the k plus 1. So does this match what we wanted to show? Yes, it does. Therefore, pk plus 1 is true. Therefore, by induction, we have b to the n equaling 2 to the n, 0, 1, 1 take 2 to the n. Great, so we've done it.